Hi, this is Stephen Dennison, class of 2012, and I'm going to do problem number 41 on page 101, chapter 4. A 15 kilogram box is released on a 32-degree incline and accelerates down the incline at 0.30 meters per second squared. Find the friction force impeding its motion. What is the coefficient of kinetic friction? Alright, so in this problem, you're looking for two things. The friction force and the actual coefficient of friction. And mu. The 2 points of the problem are to get you working with friction force and with an incline. So start out this problem like you start out any other problem, with a force body diagram. Since you're working with an angle, it's not going to be on a flat plane. It's going to look something like that. So let's draw in the forces. First you have a normal force, which is perpendicular to the incline. Then you have a weight force, which I'm going to draw dotted, and this is always going down towards the direction of the Earth. But since this is an unresolved vector relative to the positioning of the force body diagram, I'm going to resolve this into two vectors, which we will label as weight y and weight x. Alright, so we know that there's a friction force working against this. So we'll draw that in the opposite direction of the weight. So now that we're done our force body diagram, we can begin working on our equations. We have the horizontal and the vertical. For the horizontal, we are going to have a net force, or F net, which is equal to weight x minus this friction force. For the vertical, we're just going to have normal is equal to weight y. So let's start seeing what we can substitute and how we can isolate this friction force, which is the value that we'll want to find at first, since it asks you to find the friction force. So the simplest step is to subtract weight x. So now we have force net minus weight x is equal to negative friction force. And we can begin by, we know that a force is equal to mass times acceleration. And we know that this weight x is going to be equal to mg times either sine or cosine theta. And since we are working relative to this degree, 32 degrees, we know that this is going to be, even though it's weight x, and from trig you would think that would be cosine, we know that this is actually going to be sine. So let's get our values, which are mass is equal to 15 kilograms. Angle theta is equal to 32 degrees. And acceleration is equal to 0.30 meters per second squared. Alright. So now we can fill in our values. the mass is 15. Acceleration is 0.30 subtracted by 15, and then g is equal to 9.8 because it is gravity, and then sine 32. So what we get here is, when you plug this into your calculator, 4.5 minus 77.89 is equal to negative friction force. And for an answer, we're going to get negative 73, accounting for sig figs. And we can simply divide both sides by -1, and your friction force is equal to 73 newtons. Alright, so now the first step is done. But the ultimate question of this problem is, what is the coefficient of friction? So, knowing that we have this friction force equal to 73 newtons, we are going to get rid of this for now. And set friction force equal to mu times the normal force. And up here we see the normal force is equal to W, or weight Y. And then in this context, with the angle, weight Y is equal to mg times cosine theta. So we can plug that in to normal. So we're going to have 73 equals mu mg cosine 32. And we're going to end up with 73 divided by the mass, 15, and gravity, 9.8, and cosine 32. And this ratio will give us our coefficient of friction. So you do the division, and you come out to a number about 5.89, which, using sig figs, comes out to our final answer of 0.59. And that's your coefficient of friction. Alright. Do you know where he went?